Okay, so today, good news. Very good news. Today, you already know how to do this stuff. Stuff we've already done. It's just a slightly different take on skills that you already know. So going back to Unit 4, you know how to factor that, right? So if I want to factor this polynomial, you guys tell me real quick. If I factor this, it's going to break apart into pieces. What has to go there and there? You're right. How come? Go ahead. Say it again. Well, I mean, you're thinking of a factoring pattern. I need a little bit more. Yeah. Okay. Okay, so say some more about that. So what's that mean? Like, why do those have to be used if they're coming from this trinomial?
Because when you factor, listen, I would try to explain it, but I don't think I'm gonna be able to.
Well, just try.
Because the answer needs use.
Okay, the answer needs use. You're right. How come I know? Okay, so there you go. But how do I know that's like u instead of 2u or u squared? I mean, how do I know that's a u and that's a u?
Because that will come later.
Oh, there it is. Okay, good. Because if I distribute, right? Factoring means I'm unmultiplying. If I multiply all this stuff out, I should go right back where I started, right? That makes sense? I'm just reversing the process. Factoring is unmultiplying, multiplying is like kind of like unfactoring, right? So if I were to distribute here, I would have to get a u squared, right? So those have to be u's if this is going to factor. Now my magic numbers, we'll just call them m and n. What do m and n have to multiply to, the magic numbers? Negative 12, right? They have to multiply to c, and they have to add to 1. What are those magic numbers? Say it again. Negative 3 and 4, yeah. So that's going to turn that into a plus 4 and that into a minus 3, and we got it, right? It's factored. Unit 4 stuff, piece of cake. Well, we could do something slightly different than that. What if I traded those u's for something like an x squared? So I'm going to make a substitution. I'm going to substitute x squared for u. Then I would end up with, I'd end up with x squared squared plus x squared minus 12, right? Now, how would that factor? Now, what has to go there and there this time? X squared, exactly. It's got to be x squared because when I distribute, I've got to get x squared squared. What does it mean if I multiply something by itself? What is that the same as doing? Squaring it, right? 2 times 2 is 2 squared. X times x is x squared. Football times football is football squared, right? It doesn't matter what it is. If I multiply it by itself, that's equivalent to squaring it. And then the magic numbers are the same thing, right? So I would just get x squared plus 4 and x squared minus 3, and I'm done, right? Okay, that's today. Only we're going to start from a different spot. Instead of starting here, I'm going to start there. Okay, that's the same problem you guys just did. Exact same problem, but we got to see how. X to the 4th plus x squared minus 12. Now that doesn't look quadratic, does it? That looks quartic. Everybody agree? Okay, my job is to see if I can make that look like it's quadratic. So it's a unit 4 problem. Could I write that as, something squared plus something minus 12? That looks like a unit 4 problem. Could I? What would those somethings be? X squared, yeah, right? They'd be just x squareds because x squared squared is x to the 4th, right? So now that looks quadratic if I take it in pieces of x squared instead of pieces of x. When I'm thinking about this in terms of just pieces of x, it looks quartic. But if I take it in pieces of x squared, it looks quadratic, right? It looks like a quadratic trinomial. And if I factor this thing, well, now I can see that it's going to be a regular quadratic trinomial, only instead of x's, I just have x squareds where the x's would normally be, right? Okay, give me a 1 to 5 on that. Okay, that's pretty good. All right. Okay, so let's try another one. How about that guy? Everybody stare at that a second. So we want to factor this completely. It looks quartic. Can I make this thing look quadratic? What do you think? Let's just don't say anything yet. Everyone just stare at that a little bit. My goal is to make it look like something squared, not to the fourth, minus something to the 1, right? Which would be normal, minus 12. Okay. What do you think, Alexander? Is there something that could I make that happen? What would have to go in the parentheses to make that look quadratic? X squared. Yeah. Right? Everybody get that? How come? Well, because x squared squared is x to the fourth. I can just rewrite that x to the fourth as x squared squared, which works because I also have an x squared right there. Right? And now I can factor this thing. Okay, so if I break this apart, Ava, what has to go there and there? X squared. Yeah, good. It's got to be an x squared. Whoops. And we know that because x squared times x squared is going to give us x squared squared, which is the same thing as x to the fourth, right? So it works. And now what about magic numbers here? Marcus, what they have to multiply to negative 12 and add to negative 1. So what would those numbers be? Okay, plus 3 and minus 4. Okay, look at that. Okay, we're done with this, with the unit 4 problem. Is there a unit 5 problem there? Do they keep going? Can I keep factoring that? What could I do to keep going with this? What could I do, Leah? Difference of squares. Look, x squared minus 4 is the same as x squared minus 2 squared, right? So I could break this one up right here to give me what then? X squared minus 2 squared factors into what? X minus 2 times x plus 2. Can I go further with the other one? No, I can't, right? Because first of all, 3 is not a square, but even if it was, that would be the pattern a squared plus b squared. What's that pattern? Is it a pattern? No, that's the one that has no pattern. I can't factor it, right? So because I've got an x squared plus something, I know right away. I don't even have to think about it. I know that this one is stuck. It's done. So that's my final answer for this guy. That's as far as I could go. It's factored completely. Yes, Hunter. Yes, when it says factor, it means factor completely. Yeah. Okay, let's try one more of these. How about this one? Again, now that looks like a 6th degree polynomial, but the question is, it's a trinomial, right? It's got 3 terms. Could I make that look like a quadratic trinomial? That's the question. My goal is, can I make this look like something squared? There, I got a coefficient of 1 there, right? Minus 5 times something minus 24. If I can, that's quadratic, right? Okay. Nathan, what do you think? Could I do that? What would have to go in the parentheses to make that happen? Yep, that's it, x cubed, right? If I make that an x cubed, then it looks quadratic. So we could say it's quadratic in x cubed, or think of it as being like quadratic in pieces of x cubed. Okay, so if I were to split this one apart, then it's just going to factor like a regular quadratic trinomial. And what's going to have to go there and there, obviously, then, everybody? Say it again. X cubed, yeah, because I've got an x cubed squared. So these both have to be x cubed. Now, magic numbers. Karma, what do the magic numbers have to multiply to in this trinomial? Negative 24. Okay, good. So m times n equals negative 24. What do they have to add to? Negative 5? Yeah. So what would those magic numbers be? Make sure you get the signs right. You get the right numbers, but they have to add to negative 5. Negative 8, positive 3. There we go. Okay, so we could do something like this then. We could split this up so that becomes a minus 8 and that becomes a positive 3. Okay, but we have to ask ourselves, can we go further, right? We always have to ask that. Are we done factoring or can I break those factors up even more? Which one? Yeah, which one? Ah, the left one. Okay. How am I going to do that? What's that look like? Oh, okay. X cubed minus 2 cubed. Yeah, I could do that, couldn't I? I could think of this one as being x cubed minus 2 cubed, which is going to factor into two factors, right? A little one and a big one, using our difference of cubes pattern. So what's that going to give me for my little linear factor? What's my A? X. What's my B? Just 2, right? It's A cubed minus B cubed, where B is 2, right? Okay. So then what's the first factor going to be? X minus 2. There's my A minus B, right? Okay, Ellie, what's the second one going to be? Say it again. Plus, good. Times, good. So I'll call that a 2x. How about? And then 2 squared, which I'll call 4. Okay. How about that one? X cubed plus 3. Can I go any further with that? I mean, I could if 3 were a cube, right? Because there is a sum of cubes pattern, but is 3 a cube? Perfect cube? No, it's not, so I'm stuck. This one worked because 8 is 2 cubed, right? So I'm stuck with this guy then. This one can't go any further. So I just get x cubed plus 3, and there's my answer. That's factored as far as we can go, completely factored. Okay? All right, take a pause here, and let's try a little board work. Try that one. Okay, first of all, can we make that look quadratic? So my coefficients are 3, 5, and negative 12, but can I make it look like 3 times something squared plus 5 times something to the 1 minus 12? So it looks quadratic, like a unit 4 problem. What would they be? X cubes, yeah. Okay, good. So now what? What do we do? Oh, okay, yeah. Now this looks like we're factoring a quadratic trinomial where A is not equal to 1. So we've got to use slip and slide, right? Let me move this stuff. I'm going to move this stuff over here. Okay, so we're going to do a little side work then. We're going to go over here. We're going to go ahead and slip the 3 over and multiply by the 12. So that gives me x cubed squared plus 5x cubed minus 36, right? So now the question is, can we factor that? Karma, I bet that looks, we were just talking about that one. That looks pretty familiar. Numbers that multiply to negative 36 but add to positive 5 this time. What would those be? Negative 4 and 9. Good. So we know we're going to get an x cubed there and there, right? Because we got to get an x cubed squared. And we're going to get a plus 9 and a minus 4. Okay, good. So we factored the basic trinomial. What's my next step in slip and slide? Ah, good. I have to divide those magic numbers that Karma just found. I've got to divide those by the number that I slipped, which was a 3. And then I'll just reduce each of those, right? So the first factor becomes x cubed plus 3. Okay, how about over here? This fraction doesn't reduce, but what do I do if I end up with a denominator? Ah, okay, good. That's the slide part. I slide the denominator up front. So that's going to give me a 3x cubed minus 4. And so there's my answer. Okay, make sense? Okay, go to work. Put the assignment up and you can go to work.